Hey guys, my name is Alexander Coletti. This is for MSE 101, our final project presentation. For this presentation, I will be doing it on carbon-carbon composite disc brakes. Now, as you can tell from the name, they are disc brakes, which means they have plenty of applications ranging from aerospace to motorsports. However, for this presentation, we are going to be focusing on Formula One. Now, Formula One is the highest class of international racing for single-seater race cars. The word formula refers to the strict set of rules this class is forced to compete within. Now, when it comes to the manufacturing process for these disc brakes, it starts off with preforms, where sheets of carbon fiber are laid down. They then go through 3 cycles of ICVI, where they use natural gas to fill in all the pores within the material. They then go through 2 cycles of PIC, where they impregnate it with furfuryl acetone resin under pressure. This makes sure that every single micropore and every single gap is filled in. This process with ICVI just by itself can take 384 hours or 16 days of processing. After this densification has been completed, it undergoes graphitization, where it is heat treated to 2000 to 2300 degrees Celsius, converting the carbon into more of a ordered graphite-like structure. It is then machined, riveted, and sent off to the customer. Now, they are highly demanded for their incredible thermal stability. Now, in Formula One, during intense braking zones, brakes can reach up to 1200 degrees Celsius. Now, when it comes to other brake options like cast iron or steel, cast iron would melt under these temperatures and steel would start to warp and deform under these conditions. When it came to the friction coefficient, it was incredibly stable, only differing 3.9%, which was 50% lower than the 2 commercial discs tested in the study. This ensures consistent stopping power, a shorter braking distance, and an increasing safety for both the driver and onlookers. Now, the mechanical properties of this material is that it can withstand 191.2 megapascals of force. This is in the same league as hardened metals. Now, this is important because to stop, the pads push in on the rotor, and to be able to withstand these incredible forces, they have to have such a high compressive strength. They are also in high demand due to their unsprung mass. Now, the unsprung mass of a car is the weight of the car's components not supported by the suspension, and thus having a lower unsprung mass is critical to a car's handling. This results in faster wheel response to the road, improved traction, and allowing the wheel to move easier. Now, even though it undergoes densification, it is still significantly lighter than steel or cast iron brake alternatives. And in this class of racing, when every 100th of a second counts, every pound you can get rid of is a necessary one. They also have an incredible thermal conductivity and expansion. If you look at their thermal expansion, they have one where it only expands 0.8 micrometers per degree Celsius rise. Now, that is incredible because it is 1/17. Now, we'll say that again. 1/17 of steel and 1/22 of copper. Now, unlike metals that have crystal structures like HCP, BCC, or FCC, carbon-carbon disc brakes are made from sheets of carbon fiber. Now, here's when it gets a little bit complicated. It is hard to track down an exact cost because exact costs are reserved for those who are buying. However, what we can gather is when you look at Porsche's official website, if you look at their ceramic composite brakes, it goes for $10,000. Now, just as a quick reminder, Porsche's ceramic composite brakes are mass-produced, and they go through a simpler processing and manufacturing, and which results in their price. Now, when you compare that to carbon-carbon, which are not mass produced. Each are custom ordered and made and have a way longer and more complicated manufacturing process. We can only conclude that is either equal to, if not significantly greater than the $10,000 for Porsche's ceramic composite brakes. Now, in conclusion, there are many different types of brake rotors like cast iron, steel, and carbon-carbon. However, the gold standard undeniably is, as we've talked about this whole time, carbon-carbon. Whether heat tolerance, low thermal expansion, high compressive strength, or high thermal conductivity, carbon-carbon disc brakes are in a league of their own. Now here's my works cited slide. Thank you guys so much for listening, and thank you to everybody else. All the sources listed for all the figures and statistics I was able to use. Have a fantastic day, and I hope you learned something interesting.